Number 2, if this is a second way, if the limit when x approaches to plus and minus infinity of f of x equals to plus and minus infinity, and this is what you saw in the graph before. And there is a small note you have to take care about it. Only if the numerator power greater than the denominator power, you can have that information. Then the equation of the asymptote is going to be y equals ax plus b is the slant asymptote, or sometimes we call it oblique. To find the value of a or b, you have to use the following rules. A equals limit when the x approaches to plus and minus infinity of f of x over x. And to find b, the limit of x approaches to plus and minus infinity of f of x minus ax. And the a and b are real. Example, to apply these rules. If f of x equals x squared plus 2 over x minus 1, like we did before, then a has that rule. Equals limit when x approaches to plus and minus infinity for the whole function, x squared plus 2 over x minus 1. It should be multiplied in the denominator by x, like the rule. It should be multiplied by x in the denominator. Look, x is here and x is there, multiplied by the whole fraction. The whole fraction. And that will make the denominator x by x squared. And according to the way that we explained before, you are going to take the highest power up with the highest power down and cancel them, and that will give you 1. This is the way to find a. You can use the other way or the other rule to find b, which is the limit when x approaches plus and minus infinity for the whole function f of x, the whole function f of x, the whole function minus ax. A is 1. A is 1. You can write it or no need. Multiplied by x from the rule. This x from the rule. It's always supposed to be x. Now you can equal denominator by multiplying each by across denominator. X squared plus 2 minus x by x will give you x squared, minus 1 times minus x will give you plus x. You can cancel x squared with minus x squared to get 2 plus x over x minus 1. It is not that hard, it is so easy. By taking the coefficient of the x up with the coefficient of the x down and cancel them, that will give you 1. Then the equation of the slant asymptote will be written as y equals a is 1, no need to write it beside the x, plus b is 1, you have to write it because it has no variable beside, to make the equation all as y equals x plus 1. Some other ways to find the equation of the slant asymptotes, and you can have more. Finally, you can write it as a linear equation. F of x equals x squared plus 2 over x minus 1, the same example that we are dealing with. You can add and subtract by 1 to make it similar to that below. But if you subtract, you have to add in the same time to keep the fraction equivalent. Equals x squared minus 1 in a bracket, plus 1, leave it alone with a plus 2 to add it later, over x minus 1. Now you can split easily x squared minus 1 over x minus 1, plus this will be 3 after added, over x minus 1. This is a difference between two squares. You can factorize it as x minus 1 times x plus 1 over x minus 1. Then cancel them because they are common factors, plus a 3 over x minus 1. That will give you finally equal x plus 1 plus a 3 over x minus 1. Since the limit when x approaches to plus or minus infinity for f of x will go to plus and minus infinity, here if you're going to replace x by infinity, and this x by infinity, that will make it a 3 over infinity, which is 0. And that will make it infinity. Infinity plus 1 will be infinity, plus 0 will stay infinity. So the limit for the whole function when the x approaches to plus or minus infinity will go to plus and minus infinity. And this is the condition to use a slant asymptote. Then the equation of the slant asymptote is y equals x plus 1, which is exactly that part which become without a fraction, because that part will goes to 0 after you replace it by infinity. So you're going to say, right, y equals only that part. Let's now have a question from Ministry. Ministry questions. Choose the correct answer. If f of x equals x plus 1 plus 3 over x minus 1, the same equation that we discussed before, then the equation of the slant asymptote of f of x is, to find the slant asymptote, you are going to take that part like we said before without taking the fraction and equal it by y. So the answer is going to be y equals x plus 1. It's always including the two variables x and y. That will make it, the answer will be A. Number 2, the equation of the horizontal asymptote of f of x is. To find the horizontal asymptote, you have to use limit when x approaches to infinity for the whole function. Go and try to replace infinity here everywhere. Infinity plus 1 is infinity, plus a 3 over infinity minus 1 is a 3 over infinity, which is 0. So infinity plus 0 will give you finally infinity, which is not real. So non-defined. There is no horizontal asymptote. In number 3, the equation of the vertical asymptote of f of x is. To find the vertical asymptote, you have to equal the denominator by 0. Go back to the equation, equal x minus 1 by 0. By moving negative 1 to the other side, you can change the sign from negative to positive, and that will make x equals 1. X equals 1. So the answer is B. Now the answer for all is 1A, 2D, 3B. Let's have this sketch for the graph that we discuss it in different ways. The graph about f of x equals x squared plus 2 over x minus 1. You can see that broken line is our slant asymptote, which equation is y equals x plus 1, is going from left to right, rising up without touching the curve. You can draw this line easily by making a small table, plotting 3 points from your mind. For example, if you're going to put instead of x 0, so 0 plus 1 is 1. So you will plot 0 and 1. This is one of the points. You can plot others like 1 plus 1 is 2 to get 1 with 2. You can plot another point like 2 plus 1 to get a 3. 2 and 3. Then connect between the 3 lines and make it longer as possible. You can notice that your curve doesn't touch it. And remember, there is a vertical asymptote here at x equals 1 without touching it. And with a slant asymptote, the curve is going to infinity from all branches. From that branches, and that one, and that one, and that one. All branches are going infinity. Let's now make a summary for everything because we are done with the 3 types. If the domain of the function y equals f of x contains intervals such as an open interval from a to infinity or minus infinity to a opened, then if the limit when x approaches to plus or minus infinity for f of x equals to c, which is real number, then y will be equals to c, is a horizontal asymptote. So to find the horizontal asymptote, you can use this way. Limit when x approaches to plus and minus infinity, f of x, and you should get a real number. If it is not real, there is no horizontal asymptote. Number 2, if limit x approaches to c for the function f of x will goes to plus and minus infinity, then Lx will be equals to c is the vertical asymptote. And you can find the vertical asymptote without using limits. You can only equal the denominator by 0 and solve it. The last type is the slant asymptote. And if you want to find it, I give you many ways, and you can find more. One of them is if the limit of x approaches to plus and minus infinity for f of x equals to plus and minus infinity, then the equation should be y equals ax plus b, which is the slant asymptote. And this should be the condition to get that slant asymptote. Where while a equals to the limit when x approaches to plus and minus infinity for f of x over x, and b equals limit when x approaches to plus and minus infinity for f of x minus ax, and a and b should be real. This is one of the ways that you can find the slant asymptote. I give you more, and you can get more.